Alright guys, we looked in the last lesson at solving one-step, two-step, and multi-step equations, but we never got to use all of the steps from Don't Call Me After Midnight because we never had an equation with variables on both sides. So that's what we're going to be looking at today. Just a reminder, so Don't Call Me After Midnight means we're going to distribute. Call means we're going to combine like terms. And it's getting small in there. Me means move the smallest x term. And then after is going to be add or subtract. And midnight is going to be multiply and divide. So if you look in problems like number 1, we had to distribute last time. Problems like number 2, we had to combine like terms. And then in all of those, we're adding, subtracting, multiply, and divide to try to get x by itself. But we're going to look at some other problems today where there's an extra step. So on number 1, if you notice, there's nothing to distribute. Okay, we do have some like terms, but they're not on the same side of the equation. So moving that x term is kind of like combining like terms when they're on a separate side of the equation. So usually if they're on the same side, like in number 2, I just said that there's a 5x and there's an 8x, I'm going to add them together. Well, if they're on separate sides of that equals, I have to undo them. So instead of just combining them, I have to take it away from one side and do the same to the other side. So I'm usually going to pick the smaller variable. So notice I picked to take away the 2k because it's smaller than 4k. It's just going to make sure that I don't have to deal with a lot of negatives. So we're going to move that over. We're going to move the smallest x term by subtracting it. Notice I subtract it because it was positive. Opposite of adding is negative, or subtracting. And then I'm going to take that away from the left side. So 4k minus 2k leaves us with 2k. And then I'm going to bring everything else down. And now I have a nice one-step equation. So remember, we're trying to isolate the variable. We want k by itself. So we're going to undo addition and subtraction first. So I'm going to undo that subtraction on both sides. And I get 2k equals 5 plus 3 is 8. Now I've got to undo that multiplication by dividing. And k equals 4. Okay, so another example of that with some extra steps in there. So number 2, we're going to have to distribute first on both sides. So I've got, I'm going to get a 16x plus 4 equals 6x minus 21. Okay, and then we're going to take our second step and we're going to see if we can combine like terms. Well, we have some x terms and some constants, but they're on different sides of the equals. So instead of combining them, we're going to move them. So we're going to take the smallest x term, and that would be 6x, and I'm going to undo it on both sides. Okay, so that cancels out, and I'm going to be left with 10x, because I subtracted those, plus 4 equals negative 21. Okay, then we're going to do our add or subtract. So I've got to subtract 4 on both sides. It's going to get even more negative. So it's going to be negative 25. And then x is being multiplied by 10, so we have to divide. And I get x equals negative 2.5. Number 3, again, there's no distributing. We can't combine anything because they're on different sides. So we've got to move that smallest x term. That's a 3x. So I'm going to undo that. And that goes away. And I get 2x minus 2 equals 8. I'm going to undo my subtraction. And we're going to divide, not by 5, by 2 because it's being multiplied by x and we want x by itself. So x equals 5. 4, again, we've got distribute first. So I've got to distribute that 9 to both my x and my 3. So notice I went ahead and put a subtraction sign there because I see that minus sign and I know that whatever 9 times 3 is, it's going to have to be negative. So I'm going to have a negative 27 plus 3x equals 7x plus 43. And my next step after distribute is combine like terms, and I do have like terms on the left side that can be added. So I'm going to end up with 9x plus 3x is 12x. And I'm going to bring my negative 27 down, equals 7x plus 43. And I'm going to move my smallest x term because I can't combine them. I have to undo it and move it. So that goes away. And we get 5x minus 27 equals 43. And now it's just a one-step equation. So we're adding 27. And then 43 plus 27 is going to give us 70. So 5x equals 70. And then we want to undo that multiplication by dividing by 5. And if we divide 70 by 5, we find out that x equals 14. Okay, so that's how we move the variable. Let's look at some special cases really quickly. So let's try number 5. If we distribute here, I'm going to end up with 12x minus 6 equals minus 6 plus 12x. So if you look at that, so our next step would usually be to move the x value. Well, they're both the same, so if I just pick one here, those are both going to cancel out. Okay, and I'm left with negative 6 equals negative 6. If I tried to undo that negative, I would just add 6, and I end up again with 0 equals 0. So anytime we end up with a solution that is a true statement, so like anything that says negative 6 equals negative 6, because they are equal to each other, or 0 is equal to 0, that is a true statement. So that means our answer is going to be all real numbers. Okay, so anytime it's a true statement, you get down to the end and there's not a variable, or if it says x equals x, 0 equals 0, 10 equals 10, if it's a true statement, it's all real numbers. The next special case, let's look here, we're going to do some distribution. So I've got 2x plus 7 equals negative 3 plus 2x. So if I move my variables, I'm going to move that 2x on both sides. I get 7 equals negative 3. That's not true, right? So if I have 7 cookies, it's not the same thing as negative 3 cookies. I would not be as happy with negative 3. So a false statement means that we are going to have no solution as our answer. So that just means that there's not a solution to that equation. So let's look at some others. 7, if we distribute, it's going to be 18 minus 12x equals, if we distribute there, 10x plus 18. We're going to subtract our smallest variable. And I like to do, if we have a negative, I like to move that one over. So I like to add that just to keep all of our numbers positive. So that goes away and I get 18 equals 22x plus 18. Then we've got to get our x by itself, so we're going to undo that addition. And that goes away, so we end up with 0 equals 22x. Well, I still have to divide by 22. 0 divided by 22 is 0, so x is going to equal 0. And that is a perfectly fine answer. So don't stress if you see x equals 0, that's totally possible. But if you see 0 is equal to 0, that's when we have all real numbers. But 0 can be your answer. So for this one, x just equals 0. And let's look at 8. Let's see about that one. So we've got 7x plus 21 equals x plus 8. And we're going to move our smallest variable, so that's a positive. We're going to subtract it. So I've got 6x plus 21 equals 8. We're going to undo that addition. And 8 minus 21 is going to give us 6x equals negative 13. And 6 is being multiplied, so we're going to divide on both sides. And that's going to give you a pretty wonky decimal, right? Negative 13 divided by 6 is going to give us x equals negative 2.16, and 6, and some more 6s. But that's okay too, right? We can have decimals and we can have negatives. We just need to look out for these true and false statements. So if it's a true statement, if it's 0 equals 0 or 2 equals 2, that's all real numbers. If it's a false statement, 7 equals 3 or 5 or negative 3, that's going to be no solution.